All right. So how's it going, everybody? My name is Dominic Blea. Here with me today is Dominic Hernandez and Jaime Gomez. And we are Group 6. And today we're going to be talking to you guys about what we call the TX 130. So kind of a quick overview for our project. Pretty much what we decided to do was we took the Arduino Lego robot from ME210 and pretty much explored the different types of sensors out there for it, and pretty much ended up choosing two different sensors, which it was a thermal sensor and a laser diode. And we ended up coding those sensors in correlation with the Xbox remote, and which we'll be talking about a little bit later. And we also incorporated a little bit of 3D printing as well to get those stuff mounted on there correctly in terms of brackets and stuff like that, which you'll see here in a little bit later. Now, kind of the motivation behind the project, pretty much we really wanted to learn more about coding and integrating various types of sensors. Since kind of we were on lockdown, pretty much didn't really get too much hands-on with this whole virus stuff. We just really wanted to get our hands on some integrating stuff. So yeah, with that being said, we pretty much also took the design to a combat and a security type of setup, which is why we chose those two sensors, the laser diode and the thermal sensor. And we kind of chose to go that route just because we see a lot of newer robots coming out and being like monitoring robots or also security type robots. And yeah, that's kind of why we chose to go this route.
So we are using an Arduino robot that will implement certain security measures, such as firing a laser when it detects certain heat signature values. Now, there are two main modes, specifically patrol and remote control mode. So patrol mode freely roams, evading any obstacles it may encounter, and fires when the infrared sensor detects a temperature of about 76 degrees Fahrenheit. The remote control mode allows for a user to have complete control of the robot's motion, along with the firing of the laser. Now, from the remote mode, the user is able to put the robot into patrol mode and take it out whenever they please. And of course, this is done using an Xbox controller. Some of the components used was a LiDAR sensor, and this was used to determine the distance in front of the robot. So the sensor was also used to check the left and right distances when there was an insufficient amount of room in front of it. Also used an infrared sensor, and that used an 8x8 array of IR thermal sensors with a range of 23 feet and a temperature range of 32 to 176 degrees Fahrenheit. We used a laser at 5 milliwatt, a 5 milliwatt laser diode at 650 nanometers, which is in the red wavelength, of course, the Xbox controller. And we also printed a 3D robot shell to hide and protect the wires. And we also integrated a phone mount that provides a view from the perspective of the robots. And of course, using the robot, we used an ME210.
All right, hey guys, my name is Dominic Hernandez, and I'm just going to be going over the code for the robot. So in order to get the robot set up, there's a couple things that you're going to need. Of course, the gaming controller, but then you're going to have to download the software called Steam. Inside Steam, you're going to go inside the settings, big picture mode, and then you're going to go to base configurations, and then you're going to have to map out your controller in any way you feel that you need to. This is just how I did mine, so that way we can go ahead and use the controller to input values into the serial monitor and have Arduino respond accordingly, depending on what values I throw in. So going into the actual flow chart, we actually kind of have a bit here, but we just kind of start off. Basically, the robot just initializes, fixes itself inside a neutral setting, and then it awaits the user input. Working with the D-pad on the controller, you can move the robot. You can turn it left, turn it right, move it up and down. With the right stick, you can go ahead and turn the servo inside 10-degree increments, either to the left or to the right. And then you can also, by clicking up on the right stick, you can reset the servo to face forward, so that way you don't have to like constantly flip it back. The other inputs that we included are triggers and buttons. For the triggers, we include an aiming mode, and you'll see on the serial monitor once when prints on. When aiming is on, it'll toggle the laser on, and then once when the laser is off, it'll just toggle it off. Fire will blink the laser twice, and you can press that as many times as you wish. The button X on the controller will go ahead and begin your automated mode. A will break that automated mode whenever you want to. Y will continually move the robot forward, and then B will stop all motion in case if you inputted too many commands. So once when we get into the actual automated mode, basically how it starts is it just moves forward the whole way, and then it constantly reads values inside its ultrasonic sensor. Once when it reads an obstruction within 10 inches, it will stop, measure the distance to the left, then to the right. It'll determine which one's greater, and then I'll turn about 90 degrees the robot and then continue moving forward again. However, if it finds an obstruction within both 10 inches to the right and left, it'll move backward a bit and then just redo that measuring process. So now getting into the thermal part, unfortunately, we found that the Arduino Uno itself was a little bit lacking. If we had an Arduino Mega, we could have probably incorporated the thermal sensor with all the motors, but we found that it couldn't all work on just one Arduino. This was just due to lack of pins and probably just due to lack of power output. We thought that if we had a little bit of extra time and the ability to actually get another Arduino, we would include a master slave setup in which the slave will have the thermal sensor on it and the master will have everything else. So anyways, the original intention was to have that thermal sensor actually talk with the rest of the Arduino, and it'll actually follow either a hot object or it'll just keep a laser on and then move the servo to aim at wherever the hot object is at. Unfortunately, we couldn't get that, but we decided to just to prove the science of it. So what we had is we developed our code to detect a heat source that was above about 76 degrees, and then it would turn the laser on if it did, and then it would keep it off if it doesn't detect any heat source. So here's the simulation video. Hope you guys enjoy. Move up, move down, left, right. Turning on the laser so you can see the servo. Oops. And then right, and then just straight forward, left, straight forward. Cool. Complete forward, stop it, and then autonomous mode. All right, I'm just gonna turn off the music for here just so I can talk over it. So as you guys can see, the laser kind of moves around there. This is it inside automated mode. We just noticed that it would have a problem with approaching walls at an angle, but it would still fix itself after it kind of bumps into it a little bit. Right here, you can see our thermal sensor testing. This was our last test that we did, and we just go ahead and put a couple of objects above it. That was just room temperature. As you can see, the laser doesn't turn on, but as soon as I put my finger over it, boom, it turns on. We got the code to respond pretty quickly to it. As you can see, I'm going to put my front finger or middle finger over it really quickly, and you'll see it turn on and off. Boom, boom. And then finally, this is our FaceTime integration. So that way you can use the Bluetooth module and remote control the car however far you want to and still know where it's at. We just noticed that there was a little bit of trouble. If there's too many walls or objects within the way, it would end up lagging. Right here, I put it inside this automated mode, and you can just see what it does. So, oops. You don't want that to play again. All right, what we learned.
So the three main things that we learned was how to code the thermal sensor to operate in unison with the laser diode, how to implement lab techniques such as applying what we learned in Tinkercad to hands-on applications, and how to integrate new hardware such as the laser diode thermal sensor, and how to set up circuits and proper wirings.
And then this is like our references and questions page. So if you guys have anything for us,
Have any questions?
we'd be happy to answer.